This is a follow-up video to the video I did a few hours ago for Anna from California, and in this video I would cover the functions boundary.m and odmask.m. Okay, let us start debugging the code again. Where is boundary used? Okay, the boundary.m function is used here. Let me have a breakpoint here and run the code. Okay, the rest of the code was explained in the other video, and in this video let's see what happens inside boundary.m. The input to the function is 10 and then it's this image. Okay, figure I am show of k. Okay, so this is the input to your image, to your function boundary.m. Let's go inside. Step n. Okay, so this is boundary.m, and you have 8 different functions here, 8 different filters which you will be using. So this is a filter in the x direction. I say that this is in the x direction because I can see it's phi minus 3, phi here and minus 3 here. So when you look at it, look at the row in the x direction, you see some difference. And again, when you look at it in the x direction, you see some difference. In the x direction, you see the difference. So this would give you the gradient in x direction. And let us look at this function. It's minus 3, and phi. So this would also give the gradient in the x direction, but in the opposite direction. Okay, let me just show it to you on. Okay, I'll just open Paint. Okay, so do I have an arrow? So the first function is calculates the gradient in this direction, and the second function calculates the gradient in this direction. The third calculates the gradient in the upward direction, the fourth in the downward direction. I mean it's up cross, because as you can see it's minus 3 here, it's phi and minus 3. It's changing in the top right direction. Phi 0 minus 3 changing in the top right direction, phi minus 3 changing in the top right direction. So all these filters are just finding gradients in 8 different directions which you have. Okay, so we're done, and you're applying these filters onto the image. Let's see what happens here. Okay, I'll continue this. Okay, we are here now. Let me just show you what happened. Okay, we don't have k. The input image is in image. Okay, input image. So this is your image, and then when you apply h1, which is the horizontal filter, let me give you a little more intuition on what happens. What? Okay, I'm sorry. I was supposed to display the output when you apply the filter h1. Okay. Now let me show you both the images. This is the input image, and when you apply gradient, what you get is this. Now gradient in x direction, what it does is let me zoom into the optical disc maybe. Okay. It detects the difference in x direction, so it keeps calculating the gradient like this. It goes in this direction, and whenever it finds a difference, it marks it. So this is all gradient in x direction which have been plotted here. Okay, I think this should help you understand how gradients work. And let me go forward. Okay, S is going to be the size of the image, B is 0, temp is 0. Okay, and this for loop, what you're doing is you're seeing the gradient in each and every direction for each point in the image, and if the maximum of all these gradients is greater than a threshold, then you're going to set it to the threshold value. So what you're basically doing is finding the highest gradient in all the images and putting it into your final image. I hope you understand this. Okay, let's move on. Step out. Okay, okay. Okay, the next point is going after the boundary function. The next thing I was supposed to discuss was where is it? Yeah, it's OD mask. It's here. Let me continue this. Okay, so we are here at OD mask. Let's go inside. So now let's see what the input image is. So this is the input image, and then you're resizing it, saving it as green.image. That is the output again. And then h is f special of disk comma phi. Let me show you what it does. It returns you a function which is in the shape of a disk. Okay, maybe I can show it to you on the help section. F special. Okay, so it is a circular averaging filter, the disk function. So that is what this is, and you're applying this filter onto the image, and then you're not applying it onto the image, but you're applying it onto image -40. Let's see how image -40 looks like. So you're just removing the common you're just removing some threshold value from this so that the image looks better, and then you apply this averaging filter on it. Let's see how it looks. So the output is filt_image. Yeah, so the averaging filter averages everything, and your output looks like this. In this step you're doing some thresholding. So if any value on the image is more than 0.45, you set it to 1. If it's less than 0.45, you set it to 0. Now let us see how it looks like. So it looks like this. The disk is cleanly separated, and then you do some morphological operations. You apply a structural element disk which is of size phi onto this image. Maybe if you don't know about morphological operations, you should read a little more, but I'll just run very fast through this. You use a structural element of size phi, and then you get this function which bw_erode, and then you're using a disk of size 9, a structural element of size 9 to dilate the same image. It's just some morphological operations to make your image look better. And bw label, what it does is it's going to label every the objects in your image with numbers 1, 2, 3, 4 and so on. So you can read about this more in this help section. I think the video is getting long, so maybe I should complete it sooner. Okay. And region.properties, region props, what this function does is it extracts, it can extract features from an image. So it can extract various features like area, centroid, eccentricity, and also the bounding box. So here you're going to extract the bounding box from the image. So if your image is like this, the bounding box is going to be a square like this. That is what we are going to extract. So you're extracting the bounding box. It's going to be of type structure, and you're changing it to cell, and then changing it to math, saving the sizes, and then you will let me show you bb2. You have 4 coordinates. The coordinates are x1, y1, x1, y1, the size in x and the size in y. So that is the size of your optical disc, and the starting left top corner of your optical disc coordinates. What you're doing here is you're using if case 3, this is going to be 1, 3 and 1, 4. So there'll be these functions here, these numbers here. So here this is size in x into size in y, which is the area. So you're calculating the area of the bounding box. If the area of the bounding box is greater than max, and if the dimensions are less than 1.8, so the dimension in x divided by the dimension in y should be less than 0.8. So you're making sure it's so if you have something like this, it's gonna filter that out, because the ratio of direction x to direction in y is more than 1.8. So you're just setting some threshold so that it looks better. And what the whole thing does is it extracts the bounding box which has the maximum size. And then you're just doing a -1 to the x coordinates and then +10 to the optical disk. So you're just gonna have some additional bias to your coordinates. It's not going to be only the optical disk. You're going to have 2 pixels to the left and 10 pixels to the right bias. I1 is starting x coordinate, I2 is starting y coordinate, I3 is the size in x direction, I4 is the size in y direction. And then if it's less than 30, you're just doing some operations to make it look better. You can browse through it. Let me go slightly faster. And then you get A. So that this is A. Okay, let me come here. What you're doing here is if the x direction size is less than 30, then you're just adding some more bias. The top left coordinates and top right coordinate, the top left coordinates, the x coordinate and y coordinate is just getting smaller, and then and then you're increasing the size of the bias by 10. Okay, and then you get A, and you're doing some similar operations here. You're just adding bias. Okay, by adding bias, what I mean is, if this is your optical disk, you're not only going to filter this optical disk, you're going to add some bias. This is what I term as bias. Okay, anyways, I hope you got the point. Okay, let me move on. You're just adding some bias, doing the same as above, and then you're written B. Okay, let me step out, and then this looks fine. And yeah, that is it. Thank you.